Here's another example of using a t-test to test a hypothesis about the population mean. So in this example, we're looking at waiting times in a drive-through. And so previously, for this particular drive-through restaurant, the mean waiting time in line was 84.3 seconds. But the scenario here is a manager has come up with a new system and believes that this is going to reduce wait times. So after implementing this new system, the manager takes some sample data. And so here we have the wait times. So these are with the new system. And so the manager wants to test to see if this is evidence that this new system does in fact reduce wait times. So the assumption is going to be that it doesn't, and so that the mean remains at 84.3 seconds. And the theory of the manager is that this is reduced, so less than 84.3 seconds. And so let's see. Now, this is a small sample, so we'd want to make sure that this was a random sample, that there were no outliers, and that it's normally distributed. We could look at a box plot to check for outliers and at a normal probability plot to test to see if there's a normal distribution. But let's assume that those are true, that we can verify those conditions. Then we're going to proceed with the t-test. So I'm going to again use my TI-84, and under the stat menu find the test menu and option number 2, the t-test. Now in this case I actually have access to the raw data, so I'm going to choose this. I guess I need to actually put this data in, so I'm going to clear out my first list there, and I need to put in 108.5, 80.4, 67.4, 95.5, 58, 86.3, 75.9, 70.9, 65.1, and lastly 72. Okay, so those are the 10 values from my sample. Now I can go back to my stat menu and look for the test value and enter data. And so I need to tell the TI-84 what's the assumed mean. That was 84.3, the value from the null hypothesis. The data is in list 1. I can leave the frequency at 1, and this is a left-tailed test. I can calculate, and I find that the t-test value is negative 1.31, and the p-value is 0.11. That's sufficient, 2 decimal places. Now, I would need to know level of significance. So, I would say that this, the consequences of making a type 1 error, which would be rejecting this when it's true, is probably rather small in this scenario. Why don't we say that we could use a level of significance, let's say we use 10%. So this is a left-tailed test, so I'm looking for evidence over here on the left tail where 10%, the cutoff line for rejecting is the line where the area to the left is 10%. And so what is my t critical value here? So for that I will go to my distribution menu and use the inverse t function. I'm using 0.10, and degrees of freedom is 1 less than my sample size. There were 10 values in the sample, so I'll use 9. And the critical value is negative 1.38. So if I get a value to the left of this, I am going to reject. Now notice that my test value has a t-score of negative 1.31. So it is not to the left. It's somewhere close, but not quite to the left. Here's t critical. So since I didn't fall over here to the left, I'm not going to reject. Now the p-value is 0.11, and so that means that the area to the left of t critical is about 11%. The area that's to the right, I'm sorry, I say critical here, that's t-test. And it's the area that's to the left of t-test is about 11%. Here was my cutoff line, and the area to the left of that is 10%. So, when I'm comparing my p-value to alpha, this is more. There's 11% chance of me getting a value, a sample mean, as extreme as the one I did, when in fact the null hypothesis is true. So using either method, the critical value method or the p-value method, I'm going to fail to reject the null hypothesis. And so I can say there is insufficient evidence that the new system is effective, we'll say, in reducing wait times. So bad news for the manager, but good try. All right, so there's just one more example of a hypothesis test for the mean, this time when we have access to our sample data.